Hello and welcome back. We've taken this incredible journey through the algorithms that power modern AI, and today we've finally reached the summit. We are going to pull back the curtain and show you the complex, fascinating training process that turns raw data into the seamless AI chats we have every single day.
I mean, really think about it for a second. You type a question and poof, in a flash, you get a coherent, often really insightful answer. That speed is just incredible, right? But it hides this absolutely colossal effort that involves months of training, trillions of words, and some of the most powerful algorithms ever created. So how in the world does it all work? Okay, let's get into it.
So here's the game plan for this explainer. We'll start by looking at the two main phases of training. Then we'll break down the whole pre-training process. That's where the model learns about the world, and we'll talk about the sheer scale of it all. After that, we're going to explore alignment, which is what teaches the AI to be helpful. And finally, we'll tie all these ideas together to see the full picture. All right, first things first. It is absolutely crucial to understand that training a large language model isn't just one singular event. Nope. It's a really carefully structured journey that's divided into two main phases, and each one has a totally different goal. So first up, you've got pre-training. This is the big foundational learning phase. You can imagine it as the AI reading a giant library, and I mean one of the biggest libraries you can possibly imagine, just to learn grammar, facts, and how ideas connect. Then comes phase two, post-training, or what we usually call alignment. This is kind of like sending that super well-read AI to a specialized school to learn how to actually follow instructions, stay on topic, and interact in a way that's safe and genuinely helpful. Okay, so let's zoom in on that first phase, pre-training. This is where the model builds its entire foundation of knowledge about language and the world, and it does it by swimming in this enormous ocean of text. And where does all that text come from? Well, pretty much everywhere. We're talking about a huge chunk of the public internet, web pages, articles, research papers, millions of books, and these vast repositories of code. All of this incredibly diverse data is gathered up, and then it's painstakingly cleaned. And this is not a simple step, It involves complex filtering to get rid of spam, duplicate pages, and low-quality stuff, because the quality of this initial data is just so critical. It basically sets the ceiling for what the model can ever know. Now here's a key thing. A computer can't read words like you and I do. It only understands numbers. So the very next step is something called tokenization. This is the process where all that text gets chopped up into smaller pieces, we call them tokens, and each unique token gets its own special numerical ID. It's basically the AI's alphabet, and it's what allows it to process language mathematically. So, for example, the sentence, "Transformers changed AI," isn't seen as four words. Instead, an algorithm breaks it down into tokens like trans, formers, changed, and AI. By using these subword pieces, the model gets this incredible flexibility. It can handle words it's never even seen before, just by breaking them down into familiar parts. And that is way more effective than trying to memorize every single word in a language. And this brings us to the absolute core of pre-training. The model is given a sequence of tokens, and its only job, its one and only job, is to predict the very next one. That's it. It does this over and over, billions, maybe even trillions of times. And by mastering this one simple task on a massive dataset, the model implicitly learns grammar, facts, reasoning, even different writing styles. It's not just memorizing, it's learning the statistical patterns between words and ideas. Okay, now let's talk about the scale of this process, because honestly, calling it massive is a huge understatement. The amount of data and computation involved in modern AI pre-training is, well, it's almost hard to wrap your head around. We're talking about astronomical numbers here. Many of today's top models have over 100 billion parameters. You can think of parameters as all the little knobs and dials inside the neural network that get tweaked and adjusted during training. They're what actually store the knowledge the model learns. Having billions of them allows the model to capture these incredibly complex and subtle patterns in the data, way beyond what smaller models could ever do. And to train all those billions of parameters, the model processes an unbelievable amount of data, often more than 1 trillion tokens. To put that into perspective for you, that's like reading everything on Wikipedia, thousands of times over. This is why the pre-training phase is so ridiculously expensive, right? It requires these huge data centers full of specialized GPUs running 24/7 for weeks or even months, using up enormous amounts of energy. So after all of that pre-training, what we have is a model that's incredibly knowledgeable, but it's still just a raw prediction engine. It's kind of like a brilliant student who's read every textbook but has absolutely no social skills. It doesn't really know how to be a helpful assistant, and that's where the alignment process comes in. The first step in alignment is usually something called supervised fine-tuning, or SFT for short. For this, the model is trained on a much smaller but extremely high-quality curated dataset. This dataset is basically just examples of prompts paired with the ideal responses you'd want the AI to give, all written by humans. For instance, it might get an example of a request to summarize an article, along with a perfect, concise summary. This teaches the model the right format and style for being a useful assistant.
But SFT alone isn't quite enough to make the model truly aligned with our values. The next crucial step is reinforcement learning from human feedback, or RLHF, and it's a brilliant process, really. First, the model spits out several different answers to a prompt. Then, human labelers come in and they evaluate and rank those answers from best to worst. A totally separate AI called a reward model is trained on these human rankings so it can develop an understanding of what we humans prefer, what we think is helpful, accurate, and safe. Finally, the main LLM is fine-tuned using that reward model as its guide, essentially training it to produce answers that humans would score highly. This powerfully nudges the model's behavior towards what we actually want.
So, as we start to wrap this up, let's connect this whole training pipeline back to the fundamental algorithms we've been talking about. Because a large language model isn't just one magic algorithm, it's a whole stack of them, all working together, built on decades of research. Knowing how these models are trained really helps us understand their incredible strengths and their very real limitations. Because they learn by predicting the next token, they are fantastic at recognizing patterns and generating fluent, human-like text. But that exact same mechanism is why they can sometimes hallucinate or just make things up. They're just generating a statistically likely sequence of words, which isn't always the same as a true sequence of words. Their knowledge is completely limited to their training data, and they have no true understanding or consciousness. They are powerful tools for pattern matching, not thinking.
You know, we started this series with a pretty simple idea. An algorithm is just a recipe. From basic statistical learning to the very first perceptrons, to the deep learning revolution with CNNs and LSTMs, and finally to the transformers that power today's AI. As you can see here, each innovation built on the last, all culminating in the complex LLM training pipeline we've just walked through. Modern AI is the result of decades of brilliant ideas, massive data, and incredible computing power, all layered together. This whole journey, from simple algorithms to complex AI, is really all about the pursuit and application of knowledge. And on that note, we've got a quick message we'd like to share with you. Thank you for watching. Knowledge Equity Partners is a multilingual channel where we share contemporary and practical knowledge on a variety of topics that can enhance your daily lives to make it more effective and efficient. If you find our content valuable, please subscribe to Knowledge Equity Partners so you'll get notified about our daily videos. Don't forget to like, share, and spread this valuable practical knowledge with your family, friends, and community.
Let's together keep the quest for knowledge always high. Thank you again for joining us on this journey from algorithms to AI. Be sure to look out for our next episode for more information.